Okay, this is still section 1.8. Find the inverse of f of x equals 7x minus 5. So again, refer back to the list of steps that I gave you on the previous handout. First it says to replace f of x with y, so I would write this as being y equals 7x minus 5. Then interchange x and y. So that means I would have x is equal to 7y minus 5. Okay, the third step says to solve for y. So I would have first add 5. So x plus 5 equals 7y. Divide by 7. So y equals x plus 5 over 7. Then you have to determine whether or not this equation represents a function. Okay, based on what we did back in section 1.2. This is a linear equation, okay, and so that makes me know that it is a function. So if it is a function, I'm going to replace y with f inverse. Okay, and I'm just going to reverse the order that I have this written in. So it would be f inverse of x equals x plus 5 over 7. So this just represents the equation for the inverse of your function f. Okay, same example underneath. Find the inverse of f of x equals x cubed plus 1. So first, you're going to replace f of x with y. Y equals x cubed plus 1. Interchange x and y, so I would have x equals y cubed plus 1. Solve for y, so y cubed would equal x minus 1. Take the cube root of both sides. So that would give me y equals the cube root of x minus 1. Okay, so here I have to figure out, is this a function or not? Okay, if it's the cube root of x minus 1, we would have a unique value of x. If I put in, let's plug in a couple of values here. If I plug in a 2 for x, 2 minus 1 would be 1, the cube root of 1 is 1. Okay, if I plug in any other value for x, or the same value of x, it would not ever give me a different value for y. So that means this is a function. So I would have f inverse of x equals the cube root of x minus 1. So that would be my inverse function. There's a way that you can test whether or not a function has an inverse, and this is called the horizontal line test. Now remember, the vertical line test that we did earlier just tests whether or not a graph is a function. The horizontal line test tests whether or not the function has an inverse. Okay, so if I look at the graphs that are given here, which of the following graphs represent functions that have inverses? Okay, if I draw a horizontal line anywhere on this graph, it would only intersect it at one point, so that means that A would have an inverse. If I look at B, if I draw a horizontal line, it's going to intersect it 2 points here, so this would not have an inverse. Okay, and then if I look at C, I can draw a horizontal line here that intersects it at 3 points, so this also would be no. But D, anywhere I draw a horizontal line would intersect at 1 point, so that would have an inverse. Okay, number 4, this last problem that's here, or it's number 4 on my sheet. It may not be on the handout that you have, but I just wanted to show you an example. It says use the graph of f to draw the graph of its inverse. So this is just giving you a function with 3 specific points. 4, 2 is 1 point, and then -1, 0, and -3, -2. Well, to graph the inverse, all you would need to do is interchange your x's and y's. So your inverse function would have the point 2, 4, 0, -1, and -2, -3. You would just switch x and y. So if I plot those points, 2, 4 would be here, 0, -1 would be here, and -2, -3 would be here. I get this graph, which kind of looks like a mirror image, okay, and it will, but this would be the inverse of the original function.